You've probably heard the word momentum before, but what exactly is it? In physics, the formula for linear momentum is actually very simple. Here we see that the formula for linear momentum is just mass times velocity. Linear momentum, represented by lowercase p, is a vector and will always act in the direction of an object's velocity. While an object's momentum doesn't really tell us much, this concept's really important since it's another conserved quantity just like energy. If there's no net force on a system, its total linear momentum is conserved. For example, in a system where there are two objects, conservation of momentum can be illustrated by the following equation. The sum of every object's linear momentum at one time is equal to the sum at a later time. While the object's masses will stay the same, the velocities will change. So the velocities of the objects at a later time can be represented by adding a prime symbol. Let's look at the following example where two objects of different masses are moving in opposite directions towards one another. When these objects collide, they stick together and move at the same velocity. Knowing the masses and the initial velocities of the two objects, we can determine the final velocity using conservation of momentum. We can call these objects A and B to match the formula above. Plugging in the information we know into the formula above, we can see that we still have two unknowns, the final velocity of A and the final velocity of B. In this case, since the objects are stuck together after colliding, we know that both these velocities will be the same. Therefore, we can just write the final velocity as v. Doing that shows us that the final momentums of the two objects are 5 kilograms times v and 2 kilograms times v. These can be added to show that the total momentum is 7 kilograms times v. Rewriting the equation, we see that we can now just solve for v, the final velocity. Solving the equation, we find that the final velocity is 2 meters per second. This positive value means that both objects will move to the right at this velocity. It's important to note that the initial velocity of object B was plugged into the equation as negative 3 meters per second, since it's moving in the negative x direction. If we didn't do this, we would have gotten the wrong answer. The answer that we got also shows us that because object A has more momentum, the two objects will continue to move in that same direction when they join together. You might encounter other problems where the objects don't stick together after colliding, but instead move in opposite directions. In that case, one of the final velocities will be given, and you'll be asked to find the other one. In any case, you'll be able to use this same formula since momentum is always conserved. I hope that this video was helpful. If anything was unclear, comment below and I'll answer your questions. If this video was helpful, please give it a like and consider subscribing to the channel. Thanks for watching.